Welcome to 7.5. Today we're going to talk converting measurements using scale factor. Our learning objectives: you'll be able to recognize the ratio of corresponding side lengths of similar figures as the scale factor. You'll be able to use proportions to find unknown measures of corresponding parts of similar figures, be able to use diagrams of similar figures to find unknown lengths without directly measuring, and being able to solve real-world problems involving indirect measurement. Here's our introductory problem for the lesson. Make sure you read through that before moving on. You may be surprised how often we use similar figures that are related by a scale factor. Maps, architectural blueprints, and diagrams are just some examples. In most of these cases, the scale factor is given so that we know how to enlarge the items in the drawing to their real sizes. Take a look at the floor plan below. It shows where the furniture is indicated in a living room. The size of everything in the drawing has been made smaller from a real size by a scale factor. What is the scale factor for the floor plan? So to find that, we look right here. Okay? So 1 inch becomes 2 feet. Okay? So the scale factor here would be 2. So whatever we take here, we're going to multiply it by 2, and we're going to change the label to feet. So if I have this picture and I wanted to know how many feet long is the sofa, I am given that the sofa in the drawing is 2 inches long, and my unit scale is 1 inch is equal to 2 feet. So I take the 2 inches that the drawing is and I multiply it by my scale factor of 2, and I get that the sofa is 4 feet long. What if they ask about the fireplace? And here's the fireplace here at 2.5 inches. I have the same scale factor, so I take the 2.5 inches this fireplace is in the drawing, I multiply it by my scale factor of 2, and I get that the fireplace is 5 feet long. Go ahead and find the length of all of the other objects in the room. We've got the TV here, we've got the coffee table, we've got the chair, and we've got an end table. So TV, coffee table, chair, and end table. Pause the video, find all 4 of those measures, and then hit play and see how you did. Okay, you should have gotten that the TV and coffee table are both 2 feet long because they both have a drawing of 1 inch. The chair was 1.5 inches, so it is 3 feet wide in real life, and the end table was 1/2 inch in the drawing, so it would be 1 foot long in real life. Chris is making a drawing of his school and the grounds around it. The basketball court is 75 feet long and 40 feet wide. If he uses a scale factor, which is 1 inch equals 10 feet, what should the dimensions of the basketball court be in his drawing? Okay, so we are given that 1 inch is 10 feet. Okay, so if he has the basketball court is 75 feet long, we need to figure out how many times 10 feet goes into that, because that'll tell us how many inches we would have. Okay, so 75 divided by 10 gives me 7.5. So his drawing should be 7.5 inches long. Same thing can be for the width. It's 40 feet wide, and I need to divide that by my scale of 10 feet to get that the drawing should be 4 inches wide. So what I should have is a drawing that's 7.5 inches by 4 inches for a basketball court. A map is another type of scale drawing in a region. Maps can be very detailed or very simple, showing only points of interest and distances. You can read a map just like any other scale drawing by using the scale. So in our map below, the straight line distance between San Francisco and San Diego is 3 inches. What is the actual straight line distance between San Francisco and San Diego? So we set up a proportion. We write the scale as a ratio. So 1/2 inch is 75 miles. Okay. Now we can write the second ratio and make sure it follows the form of the first ratio, inches over miles. So if I have my first one, 0.5 inches over 75 miles, I want to write the second one so that it follows the same, inches over miles. So San Francisco to San Diego is 3 inches, and I don't know how many miles. So what I can do now is cross multiply. 0.5x is equal to 75 times 3, which should get me 225. To solve for x, divide by what's in front of it. I should get that the distance between the two is 450 miles. Right? So they are 450 miles apart. Here's the answer to the beginning of the lesson problem. Make sure you read through that before moving on. For review, when converting measurements, make sure you cancel out units that are diagonal from each other in the ratios that you are multiplying to determine the unit your solution has. Indirect measurement is a technique that uses proportions to find a measurement when direct measurement is not possible. A proportion is two ratios that are equal to each other. The scale factor is the ratio that determines the proportional relationship between the sides of similar figures, and similar figures are shapes that exist in proportion to each other. They have congruent angles, but their sides are different lengths.